Color management is vitally important to all print applications. Today, we will be talking about M1 paper standards. So, what is M1? M1 was developed as a standard to reduce variations when measuring color. Variation can happen between different instruments and due to several different printing and substrate factors, including fluorescence, optical brightening agents, and proofing colorants. There are two parts to the M1 paper standard. M1 Part 1 specifies the kind of light that needs to be used when measuring color. The light source should match CIE illumination D65. M1 Part 2 is a method for achieving M1 compliance that is valid only for measuring optically brightened papers, but not for inks or toners that fluoresce.
So now we're going to go a little bit more in depth into each M standard to help us better understand M standards as a whole. So on to M0, it has to do with the fact that densitometers and spectrophotometers use tungsten incandescent lighting, known as UV lighting. M1 stabilizes the interaction between the illuminant and fluorescent properties of the substrate. On to M2, which specifies complete exclusion of UV from source illuminant. M3 minimizes the effect of surface reflection by adding polarization filters, which polarization filters suppress glare in substrate or inks. So now, I'm sure you're all wondering, depending on the situation, what M standards is best. We have broken the standards down into 5 possible scenarios you can be faced with while working in the field. When neither the substrate nor imaging colorants fluoresce, you're going to want to use M0. In a situation when the substrate or imaging colorants both fluoresce, use M1 Part 1. When the substrate may fluoresce and you want to capture that fluorescence, use Part 2. When you don't want your final product you're working on to be affected by the fluorescent characteristics of the paper, you're going to want to use M2. M3 is used only in special cases where first surface reflections need to be minimized and polarization is used to do so. Below is a helpful chart on exactly what each standard does if you're more of a visual learner like me.
Now let's take a moment to talk about OBAs, optical brightening agents. First question, what are they? Optical brightening agents are chemical compounds that are added to materials like paper, laundry detergents, or cosmetic products. Alright, now a second question, what do they do? OBAs reflect more blue light in whatever material they are applied to. This effect mutes the naturally occurring yellows in these materials and enhances the naturally occurring blues. Lastly, why do we use them? To humans, this bluer tone that's added to these common materials helps present whites as cleaner or purer. In terms of trying to sell something, individuals will find a cleaner looking product vastly more appealing. Companies who produce photo albums you might buy in an arts and crafts store, or white clothing like what you might find in a new package of men's t-shirts, frequently use optical brightening agents in the manufacturing of their product because of this. OBAs can be applied to textiles and fibers for whitening purposes as mentioned before, but a more interesting application is in the cosmetics industry. Formulas of shampoos or conditioners that add a purple hue to hair can make blonde hair look more platinum. Some cosmetic powders will use OBAs to brighten darkened or shadow areas of the eyes. So how do M1 paper standards play into all of this? When it comes to running paper that is optically brightened on a press, color management systems can have problems. Although our eyes are fooled by the blue paper, spectrophotometers are not. These devices will detect the added blue and to compensate will add back in the yellows that it believes the imagery is missing. It's M1 that is the key to adjusting our measuring instruments to return more accurate readings with less variation in color. And it does this by changing the light that the colors are observed under to more accurately reflect what it is we see.
Various factors and new ideas over time have led to the adoption of the M1 standards for measuring paper brightness. Before 2009, the UV portion of the spectrum was not controlled by the industry standards for D50 color viewing and measurement. Historically, printing press papers didn't typically include optical brightening agents unless they were for higher quality jobs. In 2009, ISO created new classification measurements.
M0 is the old way of measurement with UV included. M1 is the new way with the inclusion of UV. M2 uses a UV cut filter. M3 uses a polarizing filter. The M1 measurement standards ensure proofing and press matching with Brighton stocks. Grackle 2013 stated that all calibration and color matching should be based on M1. In 2013 and 2014, new standards and profiles based on M1 were introduced, and it is now a common measurement method.
Now that you have a basic understanding of what M1 is and its history, let's dig into the pros and cons of using this standard. Some pros. M1 allows printers to generate ICC profiles for printing and proofing on OBA containing substrates. It allows us to identify appropriate proofing substrates and verify visual matches between the proof and the print in compliant lighting. So the key to this is that it's a visual match. Without M1 standards, the colors may read the same between a proof with non-OBA paper and a print on an OBA substrate, but what the human eye sees is vastly different. And above all, the pro to using this standard is the color consistency that it allows you to have, which greatly impacts the brand identity and overall quality of a product. The main con is the cost of implementing these standards. These costs can include training costs, so informing your employees and getting them trained on these standards as well as your clients. Another con and another cost is color management equipment costs. So this can be lighting, inks, machinery, floor space, and color reading devices such as densitometers and spectrophotometers. So to recap this entire presentation, OBAs are chemicals that are used to brighten paper by reflecting blue tones that appear as a brighter white to the human eye. And it creates an overall more pleasing visual. M1 is a set of standards that allows printers to get a more accurate color reading for products that are printed on OBA containing substrates or print jobs that use fluorescent colorants. So to finalize, M1 standards are necessary for color consistency. And the different segments of these standards, M1 through M4, are utilized in different situations depending on the fluorescent qualities of the print piece. So, on behalf of myself and the entire M1 team, I hope this presentation helped you gain a better understanding of what M1 paper standards are and why they are necessary. Thank you for watching.